In video number 2 here, we're going to be looking at radius and intervals of convergence. So let's go back and talk about what we're trying to do. Remember that we're talking about power series, and power series are infinite series that have, just as an example, we'll use this one. We have an infinite series, so we're adding an infinite number of terms. And if I were to write this out, it would be, let's see, 0, x to the 0 is 1 over 0 factorial, that's 1, plus x to the first is x over 1 factorial is 1, plus x to the second. So I'm just writing out these first terms here to show you, I think that's 6, yada, yada, yada. So this is the infinite series for part A. And the question is, does this series converge for specific x values? Are there any x values where I would get an answer from this infinite series here? I mean, it's the same question we've been asking ourselves for the last 2 weeks of, can an infinite series, a numerical infinite series, converge or diverge? But here I'm asking, what are the specific values, that x values, that would make it converge? Well, when I look at this, I can tell that if x equals 0, well, if x equals 0, all of these terms are going to be gone, and I'm only going to be left with 1, so it does converge. It does give me an answer. So I can say that at x equals 0, it converges. But what about if x equals 1? Will it converge? I don't know. If I substitute 1, that's going to be 1 plus 1 plus 1 half plus 1 6. Is that going to be enough to converge? We're going to have to check that. And what about x equals 2? And what about x equals negative 1? So what are the x values that are going to be guaranteed convergence for this series? That's what we're looking for when we talk about an interval of convergence, is what are the x values that would make convergence true. Now, I want to go back and highlight the fact that this value was an automatic convergence because this value was the center. So one of the reasons why we want to find the center of the power series is because we are guaranteed that the center value will produce a convergent series. So an x value of 0 will automatically make this converge, just like an x value of negative 1 would make this power series converge, and an x value of positive 1 would make this series converge. The center value is always an x value that produces convergence. The question is, are there other x values that do? And so there's only three things that can happen. Number one, the center is the only point where convergence happens. Or, number two, there's an interval of convergence. There's a starting point and an ending point, and in that window, I have convergence. I can pick any x value in this window within the interval, and I will have convergence of the series. Or, any x value and every x value causes convergence. So it's either nothing but a single point, or it's every x value, or it's an interval of x values. But notice that the interval will be symmetrical to the center. So once I know where the center is, there's going to be a certain number of spaces I go to the right and the same number of spaces I go to the left. And in that window, those x values will produce convergence. So what we're going to do is try to find a way to determine whether I have a single point convergence, or I have an interval of convergence, or I have a real line convergence, meaning it converges everywhere. So when we look at theorem 10.13 here, that's what this is telling us, that precisely one of the following has to be true. It only converges at the center, or there exists a radius measurement that if you add the radius and subtract the radius to the center, it's going to create an interval of values where the series converges, or any x value and all x values cause it to converge. R is called the radius of convergence, and the set of values is called the interval of convergence. So I do want to point out these two terms kind of go hand in hand. I can find one with the other if I know where the center is. So we're going to do this with example A here, and then we'll pause. We'll come back with example B, and we'll figure out how to do this process. How do I know if this series converges? Well, it's not a necessarily a geometric series, but what I can do is I can use the ratio test. And the ratio test says take the limit as n approaches infinity of the absolute value of the n plus 1th term divided by the nth term. And in order for this to converge, it has to be less than 1. Okay, well, let's see if we can simplify stuff. We're going to take the limit as n approaches infinity. Remember that n plus 1 factorial is n plus 1 times n factorial. And x to the n plus 1 is really x to the n times x to the 1. All of it divided by n factorial times x to the n. Can I reduce anything in this expression? X to the n's are gone, n factorials are gone, so I'm left with n plus 1 times x to the n. So I'm taking the limit as n approaches infinity of the absolute value of n plus 1 times x. Be very careful though. Well, I'm taking the limit, but the limit is as n approaches infinity. That means this is getting bigger, but the x is not. The x is not affected by the limit because the limit is only talking about n's getting bigger and bigger and bigger. So what happens as n gets bigger? This goes to infinity, so the limit is infinity. That means this is not less than 1. This limit is not less than 1, and therefore it diverges. And if it diverges, that means the only place, because we said that a power series will always converge at the center. Well, what is the center of this? The center of this is 0. So the only place it only converges at x equals 0. So we're going to say that the radius is 0 because it doesn't stretch out from that center. I'll say x equals 0, but it's really a c value because it's the center. But yes, this is one of those cases where there's only a single point convergence for this power series. I use the ratio test in order to check if this was convergent or not within a window. When we do the next video, we'll look at an example where there is an interval of values where the power series converges.